What's up, everyone? If you're new here, hit that subscribe button because we cover the cutting edge of AI and robotics that's shaping our future. And today, we're diving into something straight out of science fiction. The reveal. What is it? Meet the Amphibious Multimodal Robot, or AMR-1, developed by researchers at Zhejiang University in collaboration with China's National Robotics Lab. This isn't just another drone or underwater bot. This is the world's first fully autonomous robot that can seamlessly transition between three completely different environments: air, water, and the water's surface. Now it's relatively small, so about the size of a shoebox, weighing in at just under 2 kilograms. But don't let that fool you. The engineering packed into this thing is absolutely insane. Here's what makes it revolutionary. The AMR-1 uses what they're calling adaptive morphology. Basically, it can physically change its shape and configuration, depending on what environment it needs to operate in. When it needs to fly, lightweight propellers deploy. When it hits water, those same propellers retract, and specialized fins extend for swimming. But here's where it gets wild. When it needs to walk on water, it activates a hydrophobic surface tension system combined with rapid leg movements that distribute its weight across the water's surface. Yes, you heard that right. It literally walks on water using principles borrowed from water strider insects and basilisk lizards. The technology, how it works. So how does this actually work? Let's break down the tech. Section 1. AI Brain. First, the AI brain. The robot runs on a custom neural network that processes environmental data in real time. It uses computer vision, LiDAR, and pressure sensors to instantly recognize whether it's in air, underwater, or at the surface. And it makes transformation decisions in milliseconds. We're talking about AI that can predict the best mode of travel based on mission parameters, battery life, and environmental conditions. It's not remote controlled. This thing thinks for itself. Section 2. Shape-shifting mechanism. Second, the shape-shifting mechanism. Engineers developed a revolutionary modular design using shape memory alloys and microhydraulics. These materials can change shape when electrical current is applied. The robot has 4 primary configurations. Flight mode uses 4 rotors in a quadcopter setup. Surface mode extends hydrophobic pads and uses rapid oscillating legs. Underwater mode deploys bio-inspired fins and activates a sealed propulsion system. And transition mode, which is honestly the coolest, where it can move between these states in under 3 seconds. 3 seconds, from flying drone to swimming submarine. Section 3. Power system. Third, the power system. This was actually one of the biggest challenges. You can't use the same battery setup for flying and deep diving. So they developed a pressure-adaptive power cell that adjusts its output based on the environment. In water, it runs more efficiently. In air, it prioritizes thrust.
Real-world applications. Okay, so it's cool tech, but why does this matter? What can you actually do with a robot like this? Application 1. Search and rescue. Number 1. Search and rescue. Imagine a flood scenario. This robot can fly over the disaster zone, identify survivors, dive underwater to check submerged vehicles, and even land on the water's surface to deliver supplies, all with a single unit. Traditional rescue ops need helicopters, boats, and diving teams. This thing can do all 3 jobs. Application 2. Environmental monitoring. Number 2. Environmental monitoring. Scientists can use these robots to study ecosystems that span air, water, and coastlines. Track bird migrations, monitor fish populations, and study surface-level phenomena, all with one autonomous system. Think about coral reef research or tracking pollution across different water layers. Application 3. Military and security. Number 3, and let's be real, this is probably what China is most interested in. Military and security applications. A robot that can infiltrate via water, walk across surfaces to avoid sonar detection, then fly for aerial reconnaissance. That's a game changer for covert operations. The US Department of Defense is absolutely watching this technology. Application 4. Infrastructure inspection. And number 4, infrastructure inspection. Bridges, dams, offshore platforms, all of these require inspection in multiple environments. This robot can check underwater foundations, walk along the waterline to inspect supports, then fly up to examine the upper structure. One robot, one mission, complete data. The implications and concerns. Now, as exciting as this technology is, we need to talk about the bigger picture. Geopolitical graphics. China is publicly positioning this as a civilian research tool. But let's not be naive. Multimodal autonomous robots represent a significant advancement in both AI and robotics. Two fields where the US and China are in an active technological race. The fact that this can operate autonomously, make its own decisions, and adapt to environments on the fly, that's dual-use technology. It can save lives, or it can be weaponized. There's also the question of AI autonomy. How much decision-making power should we give machines that can operate across such diverse environments? Who's responsible when an autonomous robot makes a mistake? These aren't hypothetical questions anymore. This tech exists right now. Let's talk about privacy. A robot that can seamlessly move between environments could theoretically surveil people in ways we've never seen before. It can follow you from the air, through water, and across surfaces without needing to switch devices. What's next? So what happens next? According to the research team, they're already working on AMR2, which will be larger, have longer battery life, and include more sophisticated AI for swarm coordination. Imagine not one, but dozens of these robots working together, sharing information, coordinating movements, and covering massive areas autonomously. They're projecting commercial availability for research institutions by late 2026, with potential civilian applications by 2028. Meanwhile, you can bet that robotics labs in the United States, Europe, Japan, and South Korea are racing to develop their own versions. This has sparked a new chapter in the robotics arms race.
Outro/CTA. So there you have it. China's shape-shifting robot that's redefining what machines can do. Is this the future of robotics or the beginning of something we should be worried about? I want to hear your thoughts in the comments. If you found this fascinating, smash that like button and subscribe for more cutting-edge tech coverage. We've got videos on AI, quantum computing, and emerging technologies dropping every week. The future is here. Bye-bye. Thanks for watching.